Industrial engineers, technicians and designers have a huge role to play in the prevention of musculoskeletal disorders in companies. Following your request, here is the course that I give to you guys and to your colleagues to help you design ergonomic workplaces and workstations. This version of the course is slightly more concise than what I usually give to multinationals here in Switzerland or abroad. But if you want the full version, of course, just give me a call and we'll discuss it. I'm Olivier Girard, I'm a mechanical and industrial engineer specializing in ergonomics, and next to that I have a paramedical training in posture therapy. Therefore, I always look at ergonomics under the angle of the prevention or the management of pain, back pain, neck pain, shoulder pain, knee pain. There's a reason for that, which is simply the fact that people know what pain is, and therefore it goes directly to their mind and to their heart. However, my job is not just to protect people's health, it's to protect their health whilst increasing the productivity of the machine or of the person. And ergonomics is probably the only science that tries to find the balance between these two. Hence, the first thing we're going to do together is try and understand what musculoskeletal disorders are. What you need to understand is that basically you have only two ways to damage your health. Either you get an accident, or you suffer from musculoskeletal disorders, which is a slow phenomenon. Accidents are quick, accumulation is slow. It's something that you build up day by day throughout your habits, throughout your life at home, throughout your life at work, throughout what you do with your body, whether it's due to the impact of your production tools or whether it's due to your habits. Hence, I always represent musculoskeletal disorders as a glass that progressively gets full. And the principle is that nothing happens until something happens. If the glass is full, it means that we people have put through the faucet more than we have taken through the straw, i.e. we have loaded our bodies more than we have rested them. It can be our body as a whole, it can be our neck, our wrist, our elbow, our shoulder, doesn't matter. Therefore, the strategy will be quite simple. It will be, number one, we reduce the load, i.e. we close the tap. Number two, we increase the relaxation, i.e. the use of the straw. And number three, maybe we can discuss about the capacity of the glass, i.e. we can strengthen. As engineers, your job is mainly to work on the faucet. The rest is not your problem. Hence, you need to have a very good understanding of what hides behind the faucet. Behind the faucet, you have the 24/7 combination of posture, activity, duration, and stress. Let me take them one by one. Stress is actually psychological state. It creates muscle tension, what we call co-contraction. And your job as an engineer is typically to have reliable machines. When interfaces are messy, when there are bugs here and there, when the machine doesn't work as planned, it increases the stress. And not only is it bad for mental health, but it's also bad for physical health. It can really affect people's back and neck in particular. Then we have the biomechanical parameter, which are posture, activity, duration. Posture is kind of a tricky word because there are two meanings to posture. Posture can be whether you sit, stand, kneel, lie, or are on all fours. But it's also how do you stand, how do you sit. Right now, I'm not standing the same as right now. Okay? So posture is this complex usage pattern of every muscle and every joint. Once you have understood what is the length of each muscle and what is the angle of every joint, you have to qualify or characterize how tense people are under their skin. What will make people tense, which I call activity, are three things. Is this manual handling? Are there shocks and vibrations? Or is it cold out there? And once we have understood the shape of your body and how tense it is, we will look at everything which has to do with time, which is how long are you doing this over the month, over the week, over the day, or since last break, as well as how fast if I take the derivative of time, well, I get speed, I get frequency. The rule in biomechanics is you can only take one risk at a time. I.e., if you design an activity that involves manual handling, you should make sure that people have a proper posture and that the movement is neither fast nor too prolonged. If you design a repetitive activity, well, the posture has to be as neutral as possible and physical efforts have to be limited. You see? Of course, it's not black and white, It's the better your posture, the more repetitive can the activity be. Or the less repetitive is the activity, the heavier you can carry. Now there's a trick. The trick is that, we often hear movement is health, the best posture is the next one, you just need to design for postural variation. This is not true. Look at this guy on the picture. This guy on the picture can change his activity, say every 10 minutes. At the end of the day, his lower back will be dead. Why? Because every activity overloads the lower back. In other words, if I zoom at the lower back, I will observe the forbidden combination of a poor posture combined with a prolonged duration. And this is something that I see very often. Recently, I was doing an analysis in a biochemical company where they have, I think, 5 different types of workplaces. And what I discovered is that all the different workplaces overload the neck. So even if you organize job rotations, you're always going to overload the neck of people. So they are, say, fake job rotations. At intellectual level, they may give people the impression that they change what they're doing, but actually their neck doesn't know it, and in the end of the day, the neck will be painful. So it is not true that movement is health or that the next posture is the best one. It's not only a matter of quantity, it's also a matter of quality. Now, what's your job in all that? Well, as I've said, you have mainly an influence on the faucet, but let's get a bit deeper into that. When we look at the literature on occupational health at organizational level, so I take a bunch of people and I see what works best to, say, reduce the prevalence of musculoskeletal disorders, I see that what's most effective is to remove the risk. Yeah? Say, for example, here in Switzerland, for example, when the trash can are being removed from the streets, well, a few years ago, there were 2 people at the back of the truck who would push the big bins into the truck. That would be physical effort that would kill their back. Now we have containers that are buried in the streets, and there's no more people pushing the containers. There's a big crane taking the massive bin. The result is, of course, excellent prevention of musculoskeletal disorders, but on the other hand, there's no more work for these 2 guys who were at the back of the truck. So you see, it's very effective from a prevalence point of view to remove the risks. It can have an impact on employment. The next level is to work on the magnitude of the risk. I.e., if I take the example of these trash cans, there was a big difference between large and smaller containers, between metal and plastic containers. Large metal containers were heavier than plastic containers, and therefore they were heavier to push. Yeah? You could argue, of course, that if I reduce the size of every container, I increase the frequency. So you see, there's at some point the 2 curves will cross. It's good to reduce the weight, but if you multiply the frequency, at some point you'll lose in terms of frequency what you have gained in terms of weight. But there are other actions that you can do to reduce the magnitude of the risk. For example, proper maintenance of the bins. When they don't roll smoothly, the effort to push them is much bigger than it should be. So proper maintenance of the dustbins is a typical example of how to reduce the magnitude of the risks. Next level is work on the organization and the duration. Say typically, well, this is a too difficult task to do 40 hours a week, so we're going to employ people only 20 hours a week with that, and the rest of the time we're going to give them another type of job, say admin, for example. The problem we have there is usually a competency problem. Yeah. I mean, not everybody can do every job, especially if I think of the pharma industry. You need to be qualified for each workstation, so there are really costs involved. Plus, it becomes an organizational mess. But this is your third line of action. And what's the fourth line of action? The fourth line of action is to work on people's behavior. Why only the fourth line? Because it's the less effective. I'm a posture therapist, remember. So I do believe in improving people's behavior. But it's true that if you take a bunch of 100 people, who wants to change his or her habits? Only those who have severe pain and who have, say, the mental condition to take themselves and their life into their own hands. Yeah? And this is why at organizational level, training people on manual handling and on healthy behaviors is not the most effective line of action. However, it is very important that you train people in ergonomics and posture and all that, because it will make them able to recognize the risky situations and therefore participate in identifying technical solutions to reduce the risks. So you see, I train people, but not for them to change their behavior, for them to become my allies, the people on the field who are much better risk detectors than I am, because I cannot be everywhere at the same time when I'm, say, the engineer for the company. Now, after that, let's look at how we design ergonomic workstations, which is basically what the reason why you're looking at this video. The process that you see on these slides is a process that I've designed based on different sources, but it's an extremely powerful process to make sure that you don't miss any step. So we will take the steps one by one and make sure that you understand what hides behind all of them. Step number one is what we call the task analysis. The task analysis is understanding who does what, how, when, and why. And not only why, but why. You need to understand the full, say, chain of the causes why people do things, because very often you will realize that, oh, we do that because this. Yeah, but actually, this is not a valid reason, you know. It's because we have always done that, or because, say, the value chain is not well organized, but actually this is a useless operation, etc., etc. Or because we do this because someone else has not done his job, or whatever. So, you know, if you just ask why people do that and you take it as a data rather than a parameter, you will miss opportunities to remove operations that do not bring any added value to the work. So really question in depth, why do people do things? And very often you will have surprises. Regarding the who, it's really important that, you know, you also dig very well into who does what. What I mean with that is two things. One is, I don't care to know if it's employees who do that. You know, employees is not enough. Are they big? Are they small? Are they women? Are they men? Are they thin? Are they old? Are they young? What are they? Give you an example. In Germany, when recycling became the norm, they designed some sorting lines for people who would then put some type of trash on one side, some type on the other side. And they designed it for the German population. Yeah, except that no German guy wanted to do this job, so it was only Turkish people who were doing this job. Well, Turkish people don't have the same size as German people. So all the lines, sorting lines, were too high. This is because the who had not been questioned properly. Second part of interrogating properly the who is the following. You know, often we think of the people who do the job, but they are not only the people who do the job. They are the maintenance people, they are the cleaners, they are the external service providers, they are potentially the clients. You know, if I think of a restaurant, for example, who is the user of a kitchen restaurant? Of course the cook is, but also the guy who's going to install the machines, the cleaning staff, the waiters, maybe even the clients in some cases, God knows, you know. So the who is not only one type of people, and it needs to be described extremely precisely. And thereby you will get a whole different chain of what, how, when, why. And all these chains will have to be integrated into your design. Then let's take a population, say the worker on his machine. What I do when I design is I start with a body which is in a neutral posture. A neutral posture, well, what is it? This is a neutral posture, you see? And that is as neutral as it can be if I need to have my arms in front of me. So basically, what I've designed is a universal system which is called the 3 rules of posture, which will explain to you why 1, the back needs to be flat, 2, the neck needs to be relaxed, 3, you need to think of the body construction from the feet to the head. This system is really well detailed in the video that you see there, which is the 3 rules of posture. So I will say just advise you to look at this video on the YouTube channel so that we keep going straight to the point. Regarding rule number 2, which is that the neck needs to always be relaxed, there are 9 factors that can contract your neck, and these 9 factors are explained in the video on neck hernia. So same, take the time to look at the video to understand the 5 head factors and the 4 arm factors that you need to be able to detect if you want to make sure that people work with their neck relaxed. These 3 rules are for 90% of the situations. For you as mechanical engineers, you need rule number 4, which is a rule which will look at every joint and try to limit pressure within the joint. This pressure can come from above, say for example pressure in your knees because you're overweight. It can come from below, say for example when truck drivers jump out of their truck, well, that creates a pressure on the knee, but this time from below. Pressure against a hard surface, well, that will be the case of a mason or a carpenter who works kneeling without a pad, and actually even with a pad. Muscle contraction will compress a joint from above and below, and every time a joint is too closed, that will also increase the pressure within the joint. So all in all, how do we start in a neutral posture? Well, we start by, identifying the right basic posture. Is it sitting? Is it standing? Is it in between the two? It depends. It depends on the tact time, i.e. the cycle length. It depends on if you need to work with heavy weights or not, on the size of the object that you will manipulate, and on the precision. Basically, bear in mind that you will only sit for prolonged durations, more than 5 minutes, and that your mobility is limited when you sit. If you need a lot of mobility or a lot of strength, you better stand. Now, whenever you have someone either sitting or, say, sit standing, you need to bear in mind rule number 3, which states that to protect the spine, well, it needs to rest on strong foundations. And the foundations of the spine are in particular the pelvis. So you always need to design workstations in such a way that the pelvis is well supported. That means a lumbar support. Don't make people work on a stool. What you will encounter though is even if you make a super good design for a sitting workstation, well, that's not good enough. That's not good enough because everybody needs movement throughout the day. And therefore, here we go into a part which is either your part or the part of the manager. It can be your part in the sense that if you design a workstation which is compatible with sitting and standing, you make it possible for people to change their posture depending on what they feel. Where it's also the job of the manager is to organize job rotations. If the workstations are either sitting or standing but are not flexible, well, it's the job of the manager to organize job rotations in such a way that people get movement throughout the day. Yeah, Too much sitting is not better than too much standing. It's just different consequences. Now, next step, once I have put people in a neutral posture, what I will make sure, this is about rule number 2, is that they don't need to reach too far or to look into awkward positions. Therefore, we will discuss the height of the workstation, the depth of the workstation, and where you put the indicators. The basic rule is, well, elbow height, is, say, kind of in the middle. It's what you would do typically for computer work. But when you need precision work, such as in the watchmaking industry, for example, you need to bring the watch closer to your eyes. Look what I've done. I've done this, not that, as they usually do. And if I need to exert strength, I need to work slightly below the level of my elbows. And bear in mind that we all have different elbow heights. This is why a workstation needs to be adjustable. Then in terms of depth, well, same, it's super logical. Look, here I'm comfortable. So this is where I want to put my primary tools, those that I use the most. And the more I spread my elbows either to the side or forward, well, the less I should be using the tools. So my main tools are here, my secondary tools are there, my tertiary tools are there, and the rest is in the next room. Yeah? So same, you prioritize the space. And you see that here, this means that you really need to avoid useless stuff on the workstation. Say, for example, technical parts that the operator will not activate or will activate once a day. It's better to have the on-off button for the workstation, say, on the side than right in front of the guy, because if it's right in front of him or her, well, then that space is taken from something else, which would be then on the side. Then regarding the visual field, same, you know, it's easy to assess what your comfortable visual field here. The width is that, and when you look at a book, you don't want it to be here, you want it to be there. Yeah? So this is where you should have the indicators that you look at most, and the more you go to the side or high or down, the less frequently you should use these indicators. What I see a lot in practice, especially in the pharma companies, is that, you know, small screens are getting difficult to find. So basically they have like 21, 22, 24-inch screen, which are just for, you know, monitoring the system. And these massive things take a lot of space, where basically they are just control screens. In a company that produces pacemakers, which is a long-standing client of mine, I have managed to get them to buy 10-inch screen, which are more than enough. And as from 24-inch we went from 10 to 10-inch, and we had to review a bit the interface so that the information is clearly laid out, well, there's much more space left in the visual field for other stuff, which was before forcing people into big neck extension and rotation. So you see, what we have done now is make people stand or sit comfortably, and we have made sure that they don't go too far with their hands and that they don't go too far with their eyes. Now what I need to do is I need to zoom on each joint to check each joint against rule number 4. I mean, I can be in a very comfortable position and be working with my wrists in extension. Yeah? So this would be wrong, and at wrist level I need to change something. What you see here on this table is the concept of a closed back position. Basically, you know, a joint is two surfaces against each other. Depending on the angle of the joint, you get more or less pressure into the joint. So you need for each joint to understand, am I close to neutral or am I far from neutral, in which case there's a lot of pressure in the joint and I should avoid that. Next to the fact that I should avoid direct pressure on the joint, of course. And as you know, joints are attached to muscles and conversely. So there's a direct relationship between the comfort zone for a joint and the strength zone for a muscle. Where the joint is most comfortable is where the muscle is the stronger. There's basically a bell-shaped curve, more or less, for muscle strength. If a muscle is short or long, it's also weaker. I have another video on that, which I can link also. It's here. Now, that means that whenever you want people to exert a lot of strength, you have to make sure that their joint and their muscles are close to the neutral position. Try to hold a screwdriver or something with your wrist bent like that. No way. Whereas if your wrist is straight, then you can. One extremely important thing in ergonomics is we try to avoid efforts against yourself, like pinch grip. The design of these tasks should be changed to avoid these movements that will basically create energy, i.e. take energy from a part to throw it back into another part of you. That can lead to really serious carpal tunnel issues or epicondylitis, i.e. tendinitis in the elbow and things like this. As you can imagine, there's also a relationship between how much force you can exert and how often you can repeat the movement. Well, these curves give you some indication depending on the frequency of the movement and how long you need to repeat the movement throughout the day. After you've done your job, which is this, on, say, the people using the machine, well, you need to do the same thing for people who do the maintenance. Why? Because, of course you do the maintenance of this machine only once in a while. But your colleague at the maintenance, he spends his day going to machines which are being maintained once in a while. Therefore, if the maintenance is not planned properly for every machine, that guy is breaking his back or his neck. All these design phases should have been done with your colleagues. Don't work alone in your office. But at some point you need a formal testing. When you do the formal testing, it's important that you take different people, not only men, big, strong, young. Yeah? Take big, take small, take young, take old, and ask them accurate questions. If you ask them, do you like the workstation? Well, the answer is not going to tell you anything. Some people will not like it because they don't like the color of it, for example. Okay, good, but that will not help your design. So use of testing is extremely important, and what I mean there is also that you're never gonna get it right on the first time. Yeah, and therefore you need to say have some temporary layout and things. A company that I work with, for example, does card box design at the beginning just to see if the spacing between the machines will be alright and things like this. And little by little, the prototypes become more expensive. So you really have to work, in an agile fashion. It's like mock-ups, and they get more and more expensive because they are more and more according to what should be. The last phase is to train people in how to use their machines properly. That includes, of course, all the safety procedures and things, but that includes also what I've told you before, which is that, they have to use their body in a neutral posture. Therefore, they have to adjust their workplace. Well, teach them how to adjust it. By experience, they don't know. So you have to tell them. Now, to conclude, let's have a short discussion between engineers on norms and values. We like certainty. We'd like to think that if you do that within this norm, you're okay. Let me give you an example. The norm for elbow height when you sit for 90% of the European population, i.e. desk height for admin work, is between 68 and 76 centimeters. So if you provide everybody with the desk at 76 centimeters, you're in the norm. Well, congrats. But for 95% of your colleagues, that desk will be too high. So it's not good enough that you're in the norm. Ergonomics is not about sticking to the norm. It's more than that. It's about designing healthy workplaces and work environments. The norm is here to give you a general framework, but you need to be much more precise than that. Especially as the norms are made for a big population, but as you can see on these curves, for the American population, for example, well, they are black people, they are Latino people, they are white people, and all these guys don't have the same shape, the same size, the same morphology. Therefore, we need workplaces that are adaptable to all these different morphologies. In case you need some anthropometric data, i.e. some data on how long is the arm, how high is the elbow, here is a link of a Dutch database of the University of Delft. And of course, I mean, this is like to make you aware of certain things, but I'm very much available to help you or to train you guys, including remotely. I've just trained due to COVID, the whole team of engineers at a distance. It's not what I prefer, but it's very feasible. It works well. We do it over 2 sessions, you know. One session I explain the theory. In between the 2 sessions, you go on the field, you take pictures, you make a small analysis of the situation. And the second session, we come back all together and we have a discussion on, say, your homework. And therefore, we need to just plan 2 times, say 3 hours, and we get a really, really high level training for your engineering team. So if you like to have a discussion on that, well, here is my email and my website. Feel free to contact me. And of course, if you are just interested in understanding more how the body works, well, have a look at the posture manual. It's my entry-level product into the fantastic world of posture and ergonomics. It's based on the 3 rules of posture also. So if you really understand well everything that is in the book, probably you'll also be able to design a healthy workplace for your colleagues.